We have never seen them directly, yet we know they are there, lurking within dense star clusters, or wandering the dust lanes of the galaxy, where they prey on stars or swallow planets whole. Our Milky Way may harbor millions of these black holes, the ultra-dense remnants of dead stars. But now, in the universe far beyond our galaxy, there's evidence of something even more ominous. A breed of black holes that have reached incomprehensible size and destructive power. It's taken a new era in astronomy to find them. High-tech instruments in space, tuned to sense high-energy forms of light, X-rays and gamma rays, that are invisible to our eyes. New precision telescopes, equipped with technologies that allow them to cancel out the blurring effects of the atmosphere and see to the far reaches of the universe. Peering into distant galaxies, astronomers are now finding evidence that space and time can be shattered by eruptions so vast they boggle the mind. We are just beginning to understand the impact these outbursts have had on the universe around us. That understanding recently took a leap forward. A team operating at the Subaru Observatory atop Hawaii's Mauna Kea volcano looked out into one of the deepest reaches of the universe and captured a beam of light that had taken nearly 13 billion years to reach us. It was a messenger from a time not long after the universe was born. They focused on an object known as a quasar, short for quasi-stellar radio source. It offered a stunning surprise. A tiny region in its center is so bright that astronomers believe its light is coming from a single object, at least 1 billion times the mass of our Sun. Inside this brilliant beacon, space suddenly turns dark, as it's literally swallowed by a giant black hole. As strange as they may seem, even huge black holes like these are thought to be products of the familiar universe of stars and gravity. They get their start in rare types of large stars, at least 10 times the mass of our Sun. These giants burn hot and fast, and they die young. The star is a cosmic pressure cooker. In its core, the crush of gravity produces such intense heat that atoms are stripped and rearranged. Lighter elements, like hydrogen and helium, fuse together to form heavier ones, like calcium, oxygen, silicon, and finally, iron. When enough iron accumulates in the core of the star, it begins to collapse under its own weight. That can send a shock wave racing outward. Literally blowing the star apart. A supernova. At the moment the star dies, if enough matter falls into its core, it collapses to a point, forming a black hole. Intense gravitational forces surround that point with a dark sphere, the event horizon, beyond which nothing, not even light, can escape. That's how an average-sized black hole forms. What about a monster the size of the Subaru quasar? Recent discoveries about the rapid rise of these giant black holes have led theorists to rethink their view of cosmic history. Back in 1995, the Hubble Space Telescope was enlisted to begin filling in the details of that history. Astronomers selected tiny regions in the sky between the stars, looking north, south, and south again. For days at a time, they focused Hubble's gaze on these tiny patches of sky to examine the deepest regions of the universe. These deep field images offer incredibly clear views of the cosmos in its infancy. What drew astronomers' attention were the tiniest galaxies, covering only a few pixels on Hubble's detector. Most of them do not have the grand spiral or elliptical shapes of the large galaxies we see closer to us today. Instead, they are irregular, scrappy collections of stars. The Hubble Deep Field confirmed the idea that the universe must have evolved in a series of building blocks, with small galaxies gradually merging and assembling into larger ones. You can see evidence of this pattern simply by looking out into the sky. Many galaxies are gyrating around one another. Some are crashing together. Others ripping each other apart. Gravity calls the tune as these galaxies draw together, exchange stars and gas, and, over time, merge to form larger composite galaxies. Lately, though, this picture of a universe taking shape from the ground up has gotten a lot more complicated. The quick appearance of giant black holes and galaxies in the early universe is at odds with the gradual way matter builds up in most galaxies. They likely had their beginnings in the first generations of stars that literally burst onto the cosmic scene, in a time of incredible turbulence. These stars were born in knots that developed in the diffuse gas of the early universe.